Hello and welcome dear Mathletes once again to Mathlete Minds. We continue our journey of class 10 CBSE syllabus and now we'll take up the topic of coordinate geometry. This is the first video pertaining to it and hence we'll try to first get back and have a recap of what exactly is coordinate geometry and what are the different type of questions and the formulae that we need to understand in this particular class. Now to begin with, let's have a recap of what we did last year. What exactly is a coordinate plane? A coordinate plane is any plane surface which has been divided with the help of two mutually perpendicular lines, the x-axis and the y-axis. X-axis is always the horizontal one, the y-axis is the vertical one. Now the right side of this becomes positive, this is the negative, this OY is positive, OY dash is negative. All this you all know, and the points that we represent over here, they are they are represented with the help of an ordered pair of numbers. For example, supposing we have to represent point P45 or P43. Let's try to represent P43 and see how it is represented. Now P43, so that this is 4 over here, and then we go up with this point comes over here as 3. So this is the point P43. That means 4 is the distance from the y-axis and 3 is the distance from the x-axis. So if we generalize it and write it as xy, x is the distance from the y-axis, y is the distance from the x-axis. So all points on this plane are represented with an ordered pair. X is always the first one, y is the second one. And in the second quadrant it is negative positive, the third quadrant is negative negative, the fourth one is positive negative. So whenever you mark points, you must see the sign preceding the ordered pair of numbers. And the quadrants are always numbered in the anti-clockwise direction. This is the first one. This is the second one, this is the third one, and this is the fourth one. Now let's move on to see what type of formulae and questions we have to do in class 10. Now here we need to first do the distance formula. Now what is the distance formula? He'll find out the distance between any two points with the help of its coordinates. Here we have 2 points Px1, y1 and Qx2, y2. So we'll find the distance with the help of its coordinates. Initially, we will draw perpendiculars from P and Q on the x-axis, that is PM and Qn, and we will draw another perpendicular PR on Qn. So now we get a figure which is a combination of one rectangle over here, PMNR, and one triangle PRQ, right angle at R. So we will take the help of Pythagoras theorem, and from the triangle we get PQ square is equal to PR square plus QR square. Now, PR is equal to Mn and Rn is equal to Pn because it's a rectangle. So, moving on, what is PR? PR in terms of the coordinates will be On minus On. On minus On, which is equal to x2 minus x1. And QR will be equal to Qn minus Rn, which is equal, also can be written as Qn minus Pm. That is y2 minus y1. So pq square is equal to x2 minus x1 the whole square plus y2 minus y1 the whole square. So the distance between the 2 points pq is given by under root x2 minus x1 the whole square plus y2 minus y1 the whole square. So this is the formula. You can even rewrite this formula as x1 minus x2 the whole square plus y1 minus y2 the whole square. It's a square quantity, so it doesn't make a difference over here. And even you have done a minus b whole square is equal to b minus a whole square, so that way also you can justify. And the distance will always be positive, we won't take the negative value over here. So, and another important thing is you have to be extra careful because there is a minus sign over here. So you have to be careful when you take the ordered pairs which are negative also. Let's take an example and see the application. We have 2 points, one is minus 6, 7 and the other is minus 1, minus 5. So PQ, the distance PQ between the 2 points will be equal to, if we take this as x1, y1. Initially you can do this and later on when you become very adept you can leave on marking all this. So PQ will be x1 minus x2. So this I am writing it straight away as numbers, that is minus 6 minus 1. So we can take another bracket over here just to avoid any mistake, plus 7 minus 5 whole square. So this becomes equal to minus 6 plus 1, that is equal to minus 5 the whole square, that is equal to 25. And 7 plus 5 the whole square, that is 12. 12 the whole square is 144. So this becomes under root 169, that is equal to 13 units. So the distance between the 2 points is 13 units. Depending on what these coordinates represent, you can put the unit later on. Next question is, find the value of a when the distance between the points a, 3a and 4, 1 is root over 10. So the distance is already given as root over 10 over here. So AB is given as root over 10. And with the help of coordinates, we can write AB is equal to, if I take this as x1, y1 and this as x2, y2, I can write here as AB is equal to under root 3 minus 4 the whole square plus a minus 1 the whole square. So this becomes equal to 1 whole square, that is 1, plus a squared minus 2a plus 1 using a minus 3 the whole square. So AB is root 10 from this first condition that is given. So we can write root 10 is equal to a squared minus 2a plus 2 under root. Now to remove the radical sign, we square both the sides, so we get here 10 is equal to a squared minus 2a plus 2. So this becomes equal to a squared minus 2a plus minus 8 over here. 2 minus 10, that is minus 8. This is equal to 0. So factorizing this, we get here a squared minus 4a plus 2a minus 8 is 0. So a minus 4 plus 2, a minus 4 is equal to 0. So a minus 4 is one factor, a plus 2 is the other factor. Equating each one of them to 0, we get a as 4 or a as minus 2. Both the solutions are possible because they will both give us the distance as root 10. Next question is, find the point P on the x-axis which is equidistant from the points a minus 4, 6 and b 5, 9. So here I have taken this figure so that the understanding is much better over here. Now the important point is P is on x-axis. That means the coordinates of P will be x, comma 0. It won't have the y coordinate, the point is on the x-axis. So now if we proceed, it's given that it is equidistant from the points A and B. That means it mentions that PA is equal to PB. So what is PA? Let's calculate PA. PA will be equal to x plus 4 the whole square plus 0 minus 6 the whole square under root. And PB will be equal to x minus 5 the whole square plus 0 minus 9 the whole square. So squaring both the sides, we will get here x plus 4 the whole square plus 36 is equal to x minus 5 the whole square plus 81. So this becomes x squared plus 8x plus 16 plus 36 is equal to x squared minus 10x plus 25 plus 81. So x squared gets cancelled. So we get 18x. Now 16 plus 36, that is 52. And 81 plus 25, that is 106. So 106 minus 52, that is 54. So x is equal to 3. That means the coordinates of the point are 3, 0. So P is the point 3, 0 on the x-axis. Next one is, show that the points A, 1 minus 1, 5, 2, C, 9, 5 are collinear. Collinear means lying on the same straight line. So if we have to prove 3 points are collinear, the question can also be put up as 3 points do not form a triangle. Do not form a triangle. So in that case, you have to find out the distances between all the 3 points like AB, BC and AC and check out, and if they are collinear, definitely the sum of 2 points sum of the two distances will be equal to the third distance. Any two distance will be equal to the third distance. So let us see what is AB. AB is equal to, if you take the values directly, 1 minus 5 the whole square plus minus 1 minus 2 the whole square. That is 16 plus 9 under root, that is root 25, that is equal to 5. BC will be equal to 5 minus 9 the whole square plus 2 minus 5 the whole square. So 5 minus 9 is equal to 4 the whole, minus 9 or minus 4 the whole square, that is 16, and this is 3, that is 9. So again under root 25, that is 5. Now let's check up AC. AC will be equal to 1 minus 9 the whole square plus minus 1 minus 5 the whole square. So this becomes equal to, AC will be equal to 64 plus 36 under root, that is equal to root over 100, that is equal to 10. 10 units. So here you see AB plus BC is equal to 5 plus 5, which is equal to AC, that is 10 units. So we get sum of two distances is equal to the third distance. So these 3 points are collinear, and it's not necessary that always B will be at the center over here. It depends. You have to find out the 3 distances and see sum of which 2 distances are equal to the third distance. If they are not equal, sum of any 2 distances are not equal, then they are not collinear. Moving on to the next question, the base PQ of two equilateral triangles PQR and PQR dash with side 2A lies along the y-axis such that the midpoint of PQ lies at the origin. Find the coordinates of R and R dash of the triangles. So here we have two equilateral triangles PQR and PQR dash, which have been drawn in such a way that the base PQ, common base PQ, lies on the y-axis. So here and each side of each of the triangles measures 2A. Now let's take this triangle POR and QOR over here. Now being an equilateral triangle, we get over here this, of course, x dash OX. This will be like it's already said that the origin lies on the midpoint. The midpoint of PQ lies at the origin. So this means this is 90 degree over here. This point is 90 degree. This is 90 degree over here. So if we take this small triangle over here, OP will be equal to OQ, as these two triangles will become congruent. OPR will become congruent to OQR by RHS or SAS. RHS. So we get over here OP is equal to OQ, that is A and A. Now, if we take the triangle OPR, from the triangle OPR, we get over here OR square is equal to PR square minus OP square. PR square is 2A, the whole square, minus OP square is A square. So this is 4A square minus A square, that is 3A square. So OR becomes equal to plus minus root 3A. That means the coordinates of R are root 3A, comma 0, and R dash will be minus root 3A, comma 0. So this is way we find out the coordinates of the third vertex. Next one is, if minus 2, 0 and 2, 0 are two vertices of an equilateral triangle, then find its third vertex. So this is a same application of the previous one. Now, but here it's not mentioned which is the axis over here. But looking at the points over here, we need to understand that the points are lying on the x-axis. Minus 2, 0 and 2, 0. A and B are the 2 points over here. And they are equilateral triangles, so we can have equilateral triangles on both the sides over here. That is ABC and ABC dash. We have to find the value of C and C dash. So automatically C and C dash will lie on the y-axis. These are equilateral triangles. This is the origin, this distance is 2, this distance is 2, this is the origin over here. So this is the y-axis over here. Now, this distance, that is the BC, AC and AB, they are all equal. AB is equal to BC is equal to AC. So let us calculate AB first. AB will be equal to minus 2 the whole square plus 0 minus 0 the whole square, that is 0. We need not even write it. So this becomes equal to root 60. And then if we talk about BC or AC, now coordinate of C will be 0 comma y. So if we take AC, AC will be equal to under root minus 2 minus 0 the whole square plus 0 minus y the whole square. So this is equal to 4 plus y square under root. Now AB is equal to AC. So we can write root 16 is equal to 4 plus y square. That means 16 is equal to 4 plus y square by squaring both the sides. So this becomes y square is equal to 12, or which implies y is equal to plus minus 2 root 3. So the coordinate of C will be 0 comma 2 root 3 and C dash will be 0 comma minus 2 root 3. These will be the coordinates of these 2 points. So here in this question you must understand over here that these are vertices of an equilateral triangle. And when you look at the coordinates over here, you should rest assured that they will lie on the axis 2, 0, minus 2, 0. The distances are same, so automatically the midpoint of this base of the triangle falls on the origin. Next question is, the points A29, BA5 and C55 are the vertices of a right angle triangle at B. Find the values of A and the area of the triangle ABC. So here we have this as 90 degree. So we will be using Pythagoras theorem as well as the distance formula over here. So AC square, we have to find A. So AC square is equal to AB square plus BC square. Now AC square, that is equal to, I am taking the square, so I won't put the radical sign over here. 2 minus 5 the whole square plus 9 minus 5 the whole square. This is equal to AB square. AB square will be equal to 2 minus A the whole square plus 9 minus 5 the whole square plus BC square. BC square is equal to A minus 5 the whole square plus 5 minus 5 the whole square. So now if you look at this carefully, this 9 minus 5 whole square, that is 4 whole square, this can be eliminated from both the sides. This 5 minus 5 is 0, so this will also become 0. So we are left with 2 minus 5 whole square, that is 9, is equal to, 9 is equal to 2 minus A, that gives us 4 plus A square minus 4A, and this will become A square minus 10A plus 25, and this will become 0. This will become 0. So now if we simplify this, we get here 2A square minus 14A, and this will be, this is 4, this is 25. 29 minus 9, that is plus 20, is equal to 0. So A square minus 7A plus 10 is equal to 0. On factorizing this, we get A square minus 5A minus 2A plus 10 is equal to 0. So again we get here A minus 5 minus 2, A minus 5 is equal to 0. So A minus 5 is one factor, A minus 2 is the other factor. So A is 5 or A is 2. Now here there is something very important conclusion that we arrive at. A is equal to 5 is not possible at all, because if we take B as 5, 5, C is also 5, 5, that means they are the same point and we won't even get an equilateral triangle. B and C will completely coincide with each other. So A is equal to 5 has to be ignored. We'll take only the value of A as 2. Now if A is 2, now we have to find the area of the triangle ABC. So if A is 2, then the base BC will be 2 minus 5 the whole square that is 3 whole square, that is 9. Square root of 9, that is equal to 3. AB will be equal to, perpendicular will be equal to 2 minus A the whole square, that is 2 minus 2 the whole square, that is 0. 9 minus 5 the whole square, that is 4. 4 whole square is 16. So 16 square root is 4. So area will become half into 4 into 3, that is equal to 6 square units. So the area of the triangle is 6 square units. So the next question is, find the equation of the perpendicular bisector of AB where A and B are points 3, 6 and minus 3, 4. Also find its point of intersection with the x-axis. So here we are asked to find out the equation of this perpendicular bisector of the line which joins AB. A has the coordinates 3, 6 and B has the coordinates minus 3, 4. And this is the line PQ which is the perpendicular bisector. That means QB is equal to QA and this angle PQA is equal to angle PQB, that is 90 degrees. So we have to find the equation of this perpendicular bisector, that is PR. Now if we take these two triangles, this angle is 90, this angle is 90 and this is the common side over here and it's a perpendicular bisector, so this is equal to this. That means PB is equal to PA. By congruency we get PB is equal to PA. So let us find PB and PA. Let the coordinates of P be xy. So if I take the coordinates of P, if the coordinates of P as xy, then this becomes, PB will become x plus 3 whole square plus y minus 4 the whole square will be equal to PA, that is x minus 3 the whole square plus y minus 6 the whole square. So this is equal to x squared plus 6x plus 9 plus y squared minus 8y plus 16 is equal to x squared minus 6x plus 9 plus y squared minus 12y plus 36. So x squared y squared get cancelled. Plus 9 gets cancelled. So 6x and minus 6x, that becomes 12x. Minus 8y minus 12y, that becomes plus 4y. And 16 minus 36, that makes it minus 20 is equal to 0. Take out 4 common, you get 3x plus y minus 5 is equal to 0. So this is the equation of this perpendicular bisector. So this is the first solution. Now the question says, where does this line perpendicular bisector meet the x-axis? Now where it meets the x-axis, the y coordinate will be 0. So putting y as 0, we get 3x is equal to 5. So x is equal to 5 by 3. So the point where it meets the y-axis is, x-axis is 5 by 3, comma 0. So this is the point of intersection with the x-axis. This is the equation of this perpendicular bisector and this is the point of intersection. Now with this we come to the end of this video. I have taken up very simple questions and in the next video we will take some more questions of the first formula, then we will take up the second formula after that. So kindly like, share and subscribe to the channel. Thank you for watching.